All right, let's take a look at some function composition. We got this f of x function, we got this g of x function. Ignore any shadows we got coming from the tripod here. It's all just a little bit more interesting that way. So, if we take a look here, we've got f composed of g. Notice that is an open dot. It's not a dot. If it was a regular dot, it would be multiplication, but it is not a dot. It's an open circle there, which means we're talking about f composed of g. We're going to take this f function and compose it of the g of x function. So let's figure out this f composed of g. We're going to take this f function and we're going to leave a gap where the x is. Notice it was negative x plus 3, so I have negative gap plus 3. And where that gap is, I want to put my g of x function, and I'll even do it in a different color just so it's a little bit more interesting. In that gap, I'm going to put 2x squared plus 4x minus 6. In my parentheses goes that. And so I left a gap. I put in that g of x function. And then I just simplify because I have a negative this plus 3. I'm going to just distribute that negative right there. This gives me negative 2x squared minus 4x plus 6. That negative outside that set of parentheses changes all the signs of each of those terms. And then I have a plus 3 on the outside. Now I combine like terms. 6 plus 3 gives me 9. So I have a negative 2x squared minus 4x plus 9. And it's completely simplified, so I've now found f composed of g of x. Notice it says of x, and I still have x's in my expression. So I found that function composition. Now I want to do a very similar thing over here, g composed of f. Well, this time I'm starting with the g function, I'm composing it of the f. So I'm going to take this g function here, very similar to last time. I'm going to leave a gap everywhere I see an x. And in the gap, in a beautiful different color, I'm going to put the f of x function, negative x plus 3 here, negative x plus 3 here. And then I'm going to simplify. This is being squared. I have to do exponents first before I multiply. So this is negative x plus 3 times itself. Here, I'll wait to do this multiplication in my multiplication step. I'm going to go ahead and multiply together these two right here. 2 still on the outside. Negative x times negative x is a positive x squared. Negative x times positive 3 is a negative 3x. 3 times negative x is a negative 3x, and 3 times 3 is 9. Clean this up a little bit. We've got x squared minus 6x plus 9. Clean this up one more time. Or not really clean it up, but I'm going to distribute that too. Sounds like a good time for a different color. We've got 2x squared minus 12x plus 18. Over here we distribute that 4. We have minus 4x plus 12. Combine like terms, no like terms for our 2x squared. We've got a negative 12x and a negative 4, which gives us a negative 16x. We've got 18, 12, minus 6. Well, 18 plus 12 minus 6 is 24. And so we've now cleaned that up, and we have our g composed of f right there. One last bonus question for us here. We've got f composed of g of negative 3. How does this fit into everything? Well, it's going to be very similar to f composed of g of x. Well, the only difference is instead of x, we have negative 3. We've already found f composed of g, but we want to, instead of having x, we want negative 3. So I'm going to take this and replace the x in f composed of g. I'm going to replace the x with, you guessed it, a -3. I'll do my exponents first. -3 squared is +9. -4 times -3 is a +12. -2 times 9 is a -18. Plus 12 plus 9, -18 plus 12 is a -6. -6 plus 9 is 3. Double check just to make sure everything is bueno, and it's fantastic. So hopefully that shed some light on function compositions and really just helps us also with our simple algebra